Okay, question 1, everybody. So we have this figure 1 shows a sector. Fine, calculate the value of the radius. Okay, so we know, guys, hopefully we know, that the length, the arc length, I'll just write here, is equal to or theta. Now our length is 12, is equal to or times theta, which is 1.5, and then the radius is 12 divided by 1.5, which is 8. Okay, so the value of the radius is 8. And then we need to get this is part A, the area of the sector, part B. Well, the area is a half or squared theta, which is a half times 8 squared times 1.5, which is 64 divided by 2 is 32. 32 times 1.5 is 48. Use your calculator if you want. Okay, that, guys, is an easy start. Question 1. Question 2. Figure 2 shows a triangle. There we go. AB is 2x, AC is 3x. Okay, fine. Show that sine of ABC is equal to this. Okay, 4 marks, guys. Let me have a think. Sine of ABC, so that's this angle here. Let's call it theta. Now, unfortunately, I don't have theta, but what I can use, and guys, note that I have 3 sides and no angle, so I'm going to have to use the cosine rule. So cosine rule, I will say the cosine of theta, or let's go with 3x squared equals 2x squared plus 4x squared. 3x squared equals 2x squared plus 4x squared minus 2 times 2x times 4x times cos of theta. So we're essentially going to get cos of theta, guys, and then from cos of theta we'll get sine of theta. Now, the reason this doesn't have any x's in it is because the x's all cancel out here. But remember, angles, sine, cosine, and tan of angles are just ratios. So the fact that these are all in terms of x is pretty good for us. So you can divide by the x squared here straight away, or let me just put it in so we can all see what's happening. So it's 9x squared equals 4x squared plus 16x squared minus this is 16, 2 times 2 times 4 times cos of theta. Sorry, it's 16x squared, I should have said. 16x squared cos theta. So here, all the x squareds cancel. Gone, 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 gone. I'm dividing everything by x squared. Then let's just subtract these two here. So this is 20. 4 plus 16 is 29 minus 20 is negative 11. So negative 11 over negative 16 is cos theta. So cos theta equals 11 over 16. Now we need sine of theta, so we can use, guys, a few ways to do this. We can use the cos squared theta plus sine squared theta equals 1 identity. This is 11 over 16 squared. This is going to be sine squared theta equals 1. Let me just scroll down. We can do subtract this. By the way, that's 121 over 256. So it's sine squared theta equals 1 minus, this is 121, 11 squared over 256. Use your calculator if you need, guys. 16 squared. That is sine squared theta equals 1 minus this. Again, use your calculator, guys. That's 256 minus 121 is 135. So that would be 135 over 256, and then sine of theta is the square root of this, square root of 135 over 256. Okay, and this equals, I'll just go up here, guys, like this. This is equal to sine of theta equals the square root of 135. So we'll just split it up into, now this can help you guys, but it's going to be I believe, 9 times 15. So if we do, this is root 9 times root 15, because 15 times 9 is 135, over root 256. Root 9 is 3, root 15 is root 15, and root 256 is 16, which is what he wanted us to show. So QED. The other way, guys, which I also like, is if you just draw a triangle, like this, a right angle triangle, and then if you know this is a right angle triangle, and just put theta here. If you know cosine of theta, it's 11 over 16, adjacent over hypotenuse. And then you can calculate this using Pythagoras' theorem. This would be, well, it would actually be root 135. So then that's just using Pythagoras' theorem. Now you have sine, cos, and tan of theta. So whenever you have either sine or cos or tan of an angle, you can easily get the other three by drawing the triangle. Now obviously just be careful that it's an acute angle that you're actually trying to find. Okay, then he says, given that the area of the triangle is this, find the value of x. Okay, so I'll do it up here, guys, just so we can all see the diagram. This is area of a triangle, formula, area equals a half AB sine C. So it's 2x times 4x, 2x times 4x times sine of theta. Now he gives us the area of the triangle. It's 75 root 15 over 64 equals a half. 2x times 4x, let's just call that, well actually, sorry, let's cancel these 2's. So it's just going to be 4x squared. 4x squared. Sine theta, we now know, well, it's this. It's 3 root 15 over 16. I can divide by 4, 1 and 4. I can divide both sides by root 15. That means they are gone. I can divide, well, let's just cross multiply here. I can do 4 times 75 over 3 times 64. This equals x squared. Again, guys, use your calculator. I feel I'm almost quicker without it. So 3 into 3 goes once, 25. 4 into 4 goes once, and 16. And then x squared is 25 over 16. So x is root 25 over 16, which equals 5 over 4. Okay, obviously, guys, you do that question down here in the loads of space they give you. Okay, that is question 2. Question 3. Write down the value of log 9 base 3. Certainly, guys, with a calculator, that's easy, but the answer is 2, because 3 squared is 9. Okay. B. Solve this equation. Okay, give your answer in this form. So, first thing to note immediately is we have different bases. We have a 2 as well here that we'll deal with in a while, but first we've log base 3 and log base 9. Let's turn, generally we turn the bigger one into the smaller one, guys. So let's turn this into base 3. So this is log 9t base 3 equals log, and then we go this, so 12 over t squared over this log 9, and then I put whatever base I want, in this case 3, like this. Okay, and that is plus 2. Okay, we know, guys, that log 9 base 3 is 2, because we got it here. So let's multiply across by 2, everything by 2. So this is going to be 2 log 9t base 3 equals, this just cancels, so it's just log 12 over t squared base 3 plus 2. Okay, we could actually, oh sorry, I need to multiply this by 2. So that is 4. Now actually, we could, I just realized, guys, this is probably why he did part A. We could write 2 as log 9t base 3. That's probably how he wanted us to do it. So I'm going to write 2 as as log 9 base 3. And then it would be 2 log 9 base 3. So, okay, sorry if this is confusing, guys, but this is log 9 base 3 because of this. So, instead of 2, I'm going to put log 9 base 3. But remember, I multiplied everything by 2, so this is now 2. Okay, now everything is a log with base 3. Each term is a log with base 3. So in order to combine them and stuff, I need to get rid of these 2's, these numbers at the front, and I can do that with just raising the power. So it's 9t squared equals log 12 over t squared plus log 9 squared, which is 81 base 3. Then I can combine these two over on the right. So this is going to be log base 3, and then I do this times this, because first rule of logs, log a plus log b is equal to log ab. So this is going to be 81 times 12 over t squared. Now if you want a big bracket there. Okay, at this point, because log of this equals log of that, I can just remove the logs. I'm not dividing by logs, guys, I'm removing them. So it's 9t squared equals 81 times 12 over t squared. This is 81t squared, so that's 81t squared. This is equal to 81 times, and I'll just do 144, that's 12 squared is 144, over t squared, like this. I can then divide both sides by 81, and I'm going to get t to the power of 4. Okay, so I just want to keep my answer form here. So cross multiply, I'm going to get t to the power of 4 is equal to 144. Okay, now this means that t squared, let's go with t squared, guys, has to equal 12. T squared has to equal 12, if I just square root both sides if you like. And then t has to equal root 4 times root 3. I split this up, 4 times root 3, and I get 2 root 3, and that is the answer. That is question 3. Okay. The other way to do this part, guys, if you didn't turn that into log 9 base 3, is you can bring all the logs to the left and then remove them by doing 3 to the power of whatever's over here equals whatever the log is. Okay, that's question 3. Question 4. Show that the derivative is equal to this. Okay, this is a product rule, guys. I think this is straightforward. U is equal to e to the 3x, and v is equal to the square root of 1 plus 2x, which I'm going to write as 1 plus 2x to the power of a half. du dx is then e to the 3x. The derivative of e to the x is e to the x. The derivative of e to the 3x is e to the 3x, but chain rule times 3. So put the 3 in the front. dv dx is equal to a half times this to the negative a half, subtract 1. So multiply by the power, subtract 1 from the power. But chain rule, I have to multiply by 2. Now that 2 is going to cancel nicely with that 2. So we're just left with this. And this, guys, is 1 over the square root of 1 plus 2x. Okay, dy dx is then equal to, product rule, guys, u times dv dx, that's e to the 3x, times 1 over 1 plus 2x. That's u times dv dx plus v times du dx. So v, I'm just going to turn it back into 1 plus the square root of 1 plus 2x. V times du dx, that would be this times 3e to the 3x. Okay. Then, okay, that bit's straightforward, guys. Sorry, the rest of it is actually kind of tricky, but we're going to do common denominator. So it's common denominator 1 plus square root of 1 plus 2x. This guy's denominator, if you like, is just 1. So this is fine. It's just e to the 3x. That's the exact same. And then this guy, I have to, because it's over 1, I have to multiply the numerator by root 1 plus 2x. Now when I multiply this by root 1 plus 2x, I just get 1 plus 2x, because the root times the root gets rid of the root. And then it's this times 3e to the 3x, like this. Okay, then I guess it's just a case of simplifying. This is e to the 3x, plus 3e to the 3x, this times 1, plus 6x e to the 3x, all over this, the square root of 1 plus 2x. Okay, I just need to finish it. This becomes 4e to the 3x plus 6x e to the 3x over root 1 plus 2x equals, take out, and we'll see this is going to be this, take out 2e to the 3x, 2e to the 3x. What's left is 2 plus 3x all over root 1 plus 2x. Okay, that's part A. Part B, give your answer, find an equation of the normal to the curve with equation y equals f of x at the point of the curve where x is equal to 0. Okay, I'm going to, guys, if you don't mind, take a screenshot and do it down here. Okay, so we have the derivative. To get the normal, I need an m, and I need m equals something, and I need a point. So we get the gradient, get the point, and then we use the formula. So what's the gradient? Well, the gradient is the derivative at 0. So f dash of 0 equals, I sub in 0 here. I'm going to get 2e to the 0 times 2 plus 0 over the square root of 1 plus 0. That is 2 times 1 times 2, which is 4, over 1. So the gradient, my m is 4, but hang on, my m of my tangent is 4. The m of my normal is negative 1 over 4. It is the negative reciprocal. So this is my m. My m is negative 1 over 4. Okay, this is for the gradient. Let me just write this here. Gradient. Okay, the point I get from finding f of 0. Now it's going to be the x coordinate is going to be 0. The y coordinate we need to find using f of 0. So f of 0 is, even easier, 3 to the power of 0 times the square root of 1 plus 0, which is equal to 1. Because that's 1 and that's 1. 1 times 1 is 1. So the point is 0, 1. Okay, easy. I think this question's easier than the first question as it's worth more marks. So now I use the formula y minus y1 equals m into x minus x1. Y minus y1 is 1. It's this guy here. equals m, negative a quarter, into x minus x1, which is 0. Then I think multiply across by 4, so 4y minus 4 equals minus 1 times x, which is minus x. And then finally, if I add the x over here, I get x plus 4y minus 4 equals 0. Okay, done. That, guys, is question 4. Question 5. A circle has radius 3r and area a. Given that the value of r increases by 0.05%, use calculus to find an estimate for the percentage increase in the value of a. Okay, guys, this question is like really weird. There's the normal way to do it, but he does say use calculus. So, but the mark scheme I just checked accepts the normal way to do it. Now, the normal way. Well, let's do the normal way first. So, if the circle had radius, if it has radius 3r, if the value of r increases by 0.05, that means the multiplier would be 1.0005. That's got from, guys, when I do 0.5 over 100, and then you have to add 1 because we're going to increase it. So that means the new r, the new radius, or no, new r is, well, it's like 1.0005 r. So the new radius is 3 times 1.0005 r. Okay, and then find the percentage increase in the value of a. Okay, so the a, okay, well, let's say old a equals pi times 3r squared, pi r squared, pi radius squared, which is 9 pi r squared. And then new a is pi times this. Now, I'll just write that, guys, as 3.0015 if we times that by 3. Pi times this r squared. Now that equals, okay, let's just do one. I want to do 3.0015 squared. So 9.009. So this would be 9.009 pi r squared. Okay, then the percentage increase is just new minus old over old times 100. So I just need to do 9.009 pi r squared, new minus old 9 pi r squared, over old, which is 9 pi r squared, times 100. Okay, now I can divide everything by pi r squared. So that goes, and that goes. And then I just do 9.009 minus 9, which is 0.0. Well, sorry, this becomes, sorry, let's just do, okay, let's write it here. This minus this is 0.009 over 9 times 100, which is 0.009 divided by 9 times 100, which is 1/10. So, or 0.1. So 0.1. So the answer, therefore, percentage increase is the percentage increase. That is the percentage increase, guys. So it's 0.1%. You don't times that by 100 or anything like that. Okay, so that's the the best way to do it as far as I'm concerned, guys. He's forcing us to use calculus, so I'm going to show you how to do it. This I find this to be, I don't know, maybe even outside of the level of the course, but let me show you anyway. So we have, it says or increases by this, and we need to find the percentage increase in the value of A. So let me just write here, using calculus. Okay, so first we will say A is equal to pi r squared. So it's the original A. It's A is equal to pi times 3r squared. Okay, so this is going to be 9 pi r squared. Now, the change in, let me just move down here, guys. Let's get the ADR, the change in A with respect to R. So the change in A with respect to R is 18 pi R. Okay. Now, what we're actually trying to find, guys, because this dA means the change in A and the dr means the change in R, we need to acknowledge that we're trying to find, we need dA over A, because this is the change in A over A. And if we do this times 100, we'll get the percentage change. So this is the change in the area over the area. So if, well, let me show you with the radius. We have dr over r. Now it's not radius, sorry, it's the value of r. So r increases by 0.005. Okay, so this means that the change in r over r has to be 0. Let me just move this here. This has to equal 0.00. Well, hang on a second. It increases by 5%. So the change in r over r is 0.0005. That's this guy here. It's 0.5 over 100, which is 0.0005. So that is the change in r over r. Okay, now this, let's go back to this. We need dA over A. So what we can do is we can kind of multiply across here, if you like, by dr. Now this is why I say it's a bit outside what's expected, guys. But this is how it works. We can multiply across by this change in r. So it's dA is equal to 18 pi r dr. And we have dr over r. So, and I want dA over A. So if I divide both sides by A, let's just go dA over A equals 18 pi r over A. Now the A, well, let's just write it like this. dr like this. Okay. This is going to be dA over A equals 18 pi r dr over A. Now this original A was 9 pi r squared, like this. So this equals, let me just go down here, this equals dA over A is 2, the pi's cancel, and one of the r's cancel, so it's actually 2 over r dr. Now we know, guys, that dr over r is 0.0005. So this is dA over A equals 2 times 0.0005, which equals two of these is 0.001. So the change in A over A is 0.001. So the percentage change, therefore, percentage change is 0.001 times 100, which equals, well, that equals, guys, what we expected, 0.1%, because this, well, that's what we got the original way. So, yeah, guys, that's, look, that's how you do it. As I said, a bit beyond what I think is expected, but you can always do it this way, which you do need to know for sure. Okay, that is question 5, guys. Let's move to question 6. Show that the sum of this equals this. Okay, so it's the sum. I like to, guys, write out the sequence. So sigma notation, we start with r is 1, sub it in, 4 times 1 minus 3 is 1. Plus sum, we're adding them, sub in 2, 4 times 2, 8 minus 3 is 5. Sub in 3, 4 times 3 is 12, minus 3 is 9. And then you start to see the pattern. We're going up in 4s. It's arithmetic, fine. But we need to get the sum. The sum of an arithmetic sequence, S of n, is equal to, formula in the formula sheet, guys, it's n over 2, so we're going to keep m, n over 2, 2a, 2 times 1, plus n minus 1 times d, which is 4. Okay, n over 2, brackets, 2 plus 4n minus 4. Simplify all this, we're going to get, I don't know, divide by 2, guys, if you want. N into, that's 2 minus 4 is minus 2, divided by 2 is minus 1, so, and that divided by 2 is, okay, let's just do, I'll divide everything by 2. 1 plus 2n minus 2, which is equal to n into 2n minus 1, which is what they asked, QED. Okay, property. Hence or otherwise find the value of n such that this is greater than 1,000. So the sum is greater than 1,000. So we need to do n times 2n minus 1 has to be greater than 1,000. Okay, multiply out. This is 2n squared minus n. 2n squared minus n is greater than 1,000. And then 2n squared minus n minus 1,000 is greater than 0. Okay, then we need to solve this. Does this factorize, guys? No, it doesn't. So we'll use the quadratic formula. So let's assume it's equals for now, guys. So n equals minus b, that's 1, plus or minus the square root of b squared minus 4ac, so that's 1 minus 4 times 2 times negative 1,000, all over 4. Okay, and then we do this on the calculator. Guys, at this point, you can just go to equation, and you can even go to inequality, but let me just solve it like this first. Polynomial 2, I'll go 2 minus 1 minus 1,000, and I get this. So I get 1, okay, n equals 1 plus 3 root 8, 9. Actually, guys, I'm going to put this as a decimal. So 22.612, 22.612, or what's the next one? This same thing, guys, as a decimal, minus 22.11, minus 22.11. then that means because n has to be greater than this, so I'm going to say therefore n is greater than 22.612, therefore n, what does it ask for, guys? The least value of n is 23. For least value is 23. Okay, that's part B. Part C. Do I need to bring this down, guys? Okay, let me just do this. Okay, given that S of n is this, T of n equals this. This is the, okay, that's the nth term. And that 18 plus 3 T of n plus 7 equals S of n plus 4. Okay, guys, sorry, now that's hard to read. Find the value of n. Okay, so let's just get these two things, guys. I have T of n plus 7. That equals, I just sub in n plus 7 for n. So it's 4 times n plus 7 instead of 4n minus 3. And that equals 4n plus 28 minus 3, which is 4n plus 25. And then S of n plus 4 is equal to n plus 4 brackets 2 times n plus 4 minus 1. So I've just, again, subbed n plus 4 instead of n. This becomes n plus 4 times, this is 2n plus 8 minus 1, which is 2n plus 7. Okay, now he says 18 plus 3 of these. So 18 plus 3 of these 4n plus 25, equals this n plus 4 times 2n plus 7. Expand this 12n plus 75 equals, expand this 2n squared plus 7n plus 8n plus 28. Okay, let's get everything to the right. So it's 2n squared plus 15n minus 12n is 3n. 28 minus 18 is 10, minus 75 is minus 65, and this equals 0. Does this factorize? Okay, guys, factorize this however you like. I'm going to go 2n and n. This will be 13 times 5. I'll do 5, 13 plus minus. Okay, so the factors are 2n plus 13 and n minus 5, guys. That's my kind of quick way to do it. That's not the way I've taught most people, but just do it however you want. But these are the factors. So therefore, 2n plus 13 equals 0, or n minus 5 equals 0. This means n is negative 13 over 2, and this means n equals 5. N is a term, guys. This is a series, so we cannot have, you definitely can't have a negative term, and you definitely can't have a negative fraction term, so it has to be this one. So I'm actually just going to say reject this one, therefore n equals 5. Okay, that is question 6. Question 7. OA, BC are fixed points such that OA, OB, OC are this. Find BC as a simplified expression in terms of J and K. Okay, that, guys, I think is easy. So BC, let's do it here. A, B, C is equal to, we're going to go from B to O and then O to C. So it's B to O and then plus O to C. Now, if you want to draw it, guys, you can, but I don't think I need to. BC is BO, O to C. So BO is going to be negative this. So it's going to be negative 15i. Now, guys, I actually prefer to write this as like 15 negative 6. And OC is 8, 1. Like this. So BO is negative this. So it's going to be negative 15 and then positive 6. So I changed the sign, guys, on both of these because we're in the opposite direction. We're going from B to O and not O to B. Then OC is just 8, 1. And then we add them. So negative 15 plus 8 is negative 7. 6 plus 1 is 7. And our answer is 7, 7. But he wants it, guys. He does say in terms of I and j. So then I go back to I and j and I say minus 7i plus 7j. Now definitely, guys, you can do it all in I and j. You don't need to do it, convert into this kind of vector column form, but I do because I think it's slightly easier. Okay, part B. Find a unit vector parallel to BC. Okay, so if BC is equal to this, BC is equal to negative 7, 7. The length of BC, the magnitude of BC, is then equal to Pythagoras' theorem, the square root of 7 squared plus 7 squared. That, guys, is because, well, Pythagoras' theorem, I get rid of the negative just because negative squared is positive. This is 49 plus 49 is root 98. Okay, so the magnitude of BC is root 98. Now to get a unit vector, we divide the vector by, so unit vector, we divide the vector by its magnitude. So I'm just going to do the unit vector is 1 over root 98, 1 over root 98, and then the vector is negative 7, 7, and that's it. You can multiply in if you want. You can write in terms of ij if you want, but that is perfectly fine. Okay, the point M is the midpoint of OA, and N lies on OB such that ON to NB is 1 to 2. Show that M, N, and C are collinear. Okay, so in this example, guys, I do want to draw this out. So let's just go down here. I actually have plenty of space here. I'm going to, guys, copy the whole thing actually, just like this. Then go down here and do this. Okay, part C. The point M is the midpoint of OA. The point N is the midpoint of OB such that ON to NB is 1 to 2. Show that the points M, N, and C are collinear. Okay, so definitely, guys, now just to get my head around this, I want to draw the situation. So let's say we have, let's just draw it like, I guess this will be fine here. Okay, this is O, and I want OA is 8, 6. So let's say, sorry, 8, negative 6. So I'm going to go, let's say 8, negative 6 here. Let's say one of these is 2. So 2 for, okay, fine. 8, negative 6. This is A. And this vector here, this has a midpoint of M. Okay, so M goes in the middle. Then there is B, there's N, which is on OB such that ON to NB is 1 to 2. Okay, so B, let's just draw B, guys. It's 15 minus 6. So that'll be 8 to here. That would be 16. Let's say that's 15 minus 6. It's on the same, well, the J component is the same. So let's say this is B. And let's put in C as well while we're at it, guys. It's going to be 8, 8 here, and then let's say 1 up C. Okay, now you don't have to draw this perfectly, guys, but it might help if you can see how these are going to be collinear. Okay, so this is OB, and then N is on this such that ON to NB is 1 to 2. Now, I kind of know, guys, because these are on a straight line, it's going to be here. Now, I need to show how it's on a straight line, not just with this diagram, but it's on a straight line. And that kind of makes sense that this is like one of these is 2 of these. So that's 1 to 2, and one of these is one of these, 1 to 1, because it's the midpoint. Okay, so then we have to show that M and C are collinear. Now, to show that they're collinear, guys, all I need to show is that MN and NC are parallel, if I can show that m, n, and n, c are parallel, n lies, well, n is part of both vectors, then obviously they have to be collinear. So I'm actually going to write that, guys, because that explains to the examiner what I'm going to do. I'm going to say, need to show that m, n is parallel to n, c. Okay, so if mn is parallel to nc, then m and c are collinear. Okay, let us find m and n first. Okay, so m, the point m, guys, or I can find OM. So OM, let's do it here. OM is a half OA, and OA is 8 minus 6. So OM is a half 8 minus 6, which is 4 minus 3. And then I can find ON. ON is equal to, it is 1/3. Be careful, guys, because it's in the ratio 1 to 2. So this is like 1/3, and this is 2/3 of the line. So it's 1/3 of OB, a third OB. And OB is 15 minus 6. So this is equal to a third of 15, which is 5, and negative 6, a third of that is negative 2. Okay, so now I have OM and ON. Now I just need to get MN and NC. Okay, I'm going to do this. Well, I'll do it here, guys. MN equals, MN is M to O, plus O to C. MO is, again, negative this, guys, because this is OM. So MO is negative 4, positive 3. And then plus OC, which is 8, 1. Okay, this is equal to 4, 4. I just add the I components and add the j components. Okay, so that's 4, 4. And then NC, let's just come down here. NC is equal to, again, I'll do NO plus OC. NO we have here, but again, it's negative. So this is going to be negative 5, 2, plus OC is again 8, 1. Add these, and I get 3, 3. Now, these are, guys, hopefully you can recognize straight away they are parallel, because they both, well, they're both going in the direction 1, 1, if you want to think of it like that, 45-degree angle. But they are definitely parallel. So I'm going to say I'll say MN is equal to 4 over 3 times 3, 3. If I just do this divided by this, so it's 4 over 3, 3, 3, which is 4 over 3 times NC. Therefore, parallel. Therefore, M and C are collinear. Sorry, guys, 2 L's. Collinear. Okay, great, done. That is question 7. Next, question 8. Complete the table of values for y equals 2 plus ln of 2x plus 1, giving your answer to 2 decimal places. Okay, so guys, I'm going to do this with this calculator. However, if you have a graphing display calculator, you can literally just draw it, and then depending which one you have, you can kind of trace and find these values. With this one, the way we do it is you go to function, then define f of x, and then you type in, I've actually done it already, guys, but you type in, I'll show you how to do it, 2 plus ln is here, so it's shift this, ln of 2x plus 1, enter. Okay, then we have to go to the table, And then here, I'm going to just type in x values and it will give me y values. So for example, if I type in 2, it should give me, sorry, if I type in 0, it should give me 2. And it does for f of x, error for g of x because I haven't defined that. Okay, so I'll do 0.25, I'll do 0.5, and I'll do 3. And these are my values, 2.41, 2 decimal places, guys, 2.41, 2.69, 3.95. Okay, that is 2.41, 2.69, and 3.95. Okay, then he says, on the opposite grid, draw this graph. So very easy. I just plot these points. 0, 2 is here. 0.25 is here, and it's 2.41. So this is 2 point. This is, guys, this is 2.5. So this is 2.5, and this is 2 point, sorry, I want 2.4. So that's 2.1, 2.2, 2.3, 2.4, 2.41, somewhere there. 2.69 will be 0.5, so 2.69, 2.5, 2.6, 2.69, somewhere there. 1 is 3.1, so 1, 3.1 is like there. 1.5, 3.39, so that's 3.1, 2, 3, 9, something like there. You do need to be somewhat accurate, guys. 2 is 3.61, so 3.5, 3.6, 3.61 is like there. And finally 3 is 3.95, 3.95 will be exactly here. Now, does that look right, guys, for a log function? I actually find this one's a little bit out of place there, so 3.1, well, that is right for 3.1, which means, is this one right? 1.5, 3.39, 3.1, 3.2, 3.3. Yeah, I think that one could just be a little bit higher. I always do that, guys, when you're about to draw. Just look, does it? Log graph does kind of do that, so, okay. Now he says from 0 to 3, so I'm going to stop when I get to that there. Okay, now, it should be a nice curve. Okay, that's not good enough. Nice curve through the points. Okay, that, guys, that actually isn't good enough, but I'm not going to draw it again, so just make sure you draw it properly. Okay, part C. Here we go. By drawing an appropriate straight line on the grid, obtain an estimate to 1 decimal place of the root of the equation this equals this. Okay, so the way we do these questions, guys, hopefully you've come across these before, but we basically have to turn one side of the equation into the graph. So the graph is 2 plus ln of 2x plus 1. So I need to turn this into 2 plus ln of 2x plus 1. So the first one's pretty straightforward. I just need to add 2 to get 2 plus ln of 2x plus 1. But if I add 2 to the left, obviously I need to add 2 to the right. So this becomes 3x minus 2. Minus 4 plus 2 is minus 2. So now this is the same as this. Look, you can see it. This is the same as this. So this is now y. So I need to draw y equals 3x minus 2. Okay. Hopefully, guys, you know how to draw 3x minus 2. I personally just like to find any 2 points that fits nicely. So let's go with, when x is 0, normally I would choose, but that's not going to work. When x is 1, y is 1. So there's a point. And when x is 2, y is 4. So 2, 4. So 2, 2. Sorry, I said 1, 1. That's definitely not right. 1, 1 is here. And 2, 4 is here. Okay. Then draw this line down like this. And where they intersect, which is here, is where I am going to have my answer. So let's go straight down to here. He says to 1 decimal place, so that's 1.5, 6, 7, 8, 9, 1.9. It says mark scheme guys says except x equals 1.8 or 1.9. I'm going to go with 1.9. That's the solution. Okay, part D. Let's do it here. Okay, this one's definitely harder, guys. He says, by drawing an appropriate straight line on the grid, same thing, obtain an estimate to 1 decimal place of the root of this equation. Okay, so I have e to the 6 minus x minus 2x plus 1 squared equals 0. Now the goal is the same, guys. I need to get this 2 plus ln of 2x plus 1. There's a 2x plus 1 here, so I'm definitely going to thinking like I need to just ln this. But a bit of a problem. I can't really just ln across. It doesn't really work like that. So what I can do is just rearrange. So I can make this e to the 6 minus x equals 2x plus 1 squared. Add it to the right. And then I can ln both sides. I'm just going to scroll down a bit here, guys. I can now say ln of this, e to the 6 minus x, equals ln of this, 2x plus 1 squared. Now ln of e to the 6 minus x just equals 6 minus x. That's true because a few ways to think of it. You could bring the 6 minus x in front, and then ln of e is 1, because e to the power of 1 equals e. Or just, you know this rule, ln of e to the power of x equals x, because you're like raising it to the power and then logging it to the base with the same base. So it's kind of like they cancel. It's like squaring a square root. Anyway, you're left with 6 minus x. In this one, I'm going to bring the 2 in front, so I get 2 ln 2x plus 1. That is a rule, like the third rule of logs, the power rule. Okay, so now my goal is to get this, guys. I'm not quite there yet. First thing I'm thinking, I don't like this 2 because it's not plus 2, it's times 2, so I need to get rid of this 2. So let's divide by 2. So I'm going to have 3 minus x over 2 equals ln of 2x plus 1. So we're nearly there, but I need to just add 2. So ln of 2x plus 1 equals 3 plus 2, which is 5, minus x over 2. So similar thing, I need to draw y equals 5 minus x over 2. Same way, I'll just draw it like this, guys. Again, you can do it with your calculator if you need to. I find this is quicker. I'll sub in an even number, guys, because I'm going to divide by 2. So I'm going to sub in 2. 5 minus 2 over 2 is 5 minus 1, which is 4. And then I'll sub in 4. 5 minus 4 over 2 is 5 minus 2, which is 3. So my 2 points are 2, 4, and 4, 3. So 2, 4 is here. This is that same point, 2, 4. And 4, 3 is here. And then I draw this line, and where they meet is here. This is going to be my solution. So it's around 2.4, 2.5. It actually, the answer says except 2.4 or 2.5. So my solution is, let's just go with x equals, mine's slightly nearer to 2.5. So I'll go with 2.5. Okay, that, guys, is question 8. Question 9, figure 3 shows a solid cuboid. Here we go. We're given these. The volume is this. Total surface area is this. Show that the surface area is this. Okay, so guys, this is to me a familiar question. I've seen this before. I know how to do it. First, we get volume is equal to, so this times this times this. So 3x squared times h equals 540, And then we get the surface area. Let's do that first, I guess, in terms of everything. Surface area is equal to, so 6 faces, guys. They come in pairs because it's a cuboid, so it's this times 2, and then the bottom one times 2. I'll do this one first. It's xh times 2, so that's 2xh. It's then this one times 2, 3xh times 2, which is 6xh. And then it's 3x squared times 2, which is 6x squared. This is equal to 8xh plus 6x squared. Okay, so this is s, but in his formula there is no h. So how do I get rid of this h? Well, I use this volume formula to get rid of it. So I'm just going to do it here, guys, to save me space. When I rearrange this, I can say h equals 540 divided by 3x squared. So I'm making h the subject so that I can sub that into h here in s, which will hopefully give me that. Okay, so this gives me 8x h. H is this thing, 540 over 3x squared plus 6x squared. Now, when you multiply this out, guys, 8 times 540 divided by 3, I'm guessing 8 times 540 divided by 3, I'm guessing we get 1440, and we do. So this is 1440. Notice the x squared is on the bottom, the x is here, so I do 1440 over x, and then this is plus 6x squared, which is what we were asked to show. So I'm going to write QED. Okay, done. That is part A. Part B. Use calculus to find the 3 significant figures the value of x, which s is a minimum. So we're finding the minimum. Minimum, guys, is derivative equals 0. And then justify that it's a minimum. That is second derivative. So let me just write that here, guys. First derivative is minimum. First derivative ds dx equals 0. And then justify that it's a minimum here. That is second derivative d2s dx squared must be greater than 0 for a minimum, guys, because it's concave up. The second derivative is greater than 0. Okay, so let's get the first derivative. First derivative, I'm just going to rearrange this, guys, to be 1440x to the minus 1 plus 6x squared. Differentiate this, ds dx equals negative 1440x to the minus 2 plus 12x. Okay, now we want this to be equal to 0, so I'm going to do negative 1440 over x squared, that's the minus 2, plus 12x equals 0. I am going to, guys, if you're okay with this, add this negative thing to the other side over here. So I'm going to end up with 12x equals 1440x. 1440 over x squared. Then I will multiply across by this x squared, and I get 12x squared. Let's move down a bit. I get 12x squared equals 12x cubed, because I'm multiplying across. So 12x cubed equals 1440, and then x cubed is equal to 1440 divided by 12. 1440 divided by 12 is 120. Okay, so x cubed is 120, which means x is the cubed root of 120. The cubed root of 120 is 4.9324. 4.9324. Now I'm writing the whole thing down, guys. 4.9324. No, sorry, not the whole thing, but more than 3 significant figures. Although I'll use 3 significant figures here because I may use that number after, and then I don't want it to be rounded. So I'll write that and then the rounded version. Okay, so that's x, but that's the ds dx equals 0. But now we have to justify it. So now we have to find d2s dt squared, d2s, sorry, dx squared. And this is equal to, so now I'm going to differentiate this. So minus 2 times this is plus, so it's going to be 2 times that, which is actually 2880 x to the power of minus 3 plus 12. Derivative of 12x is just 12. And then at x equal 4.93, this is equal to d2s dx squared equals 2880 over 4.93 cubed, because it's x to the minus 3 is divided by x cubed, so this cubed, plus 12. Now, I don't even need to evaluate that, guys, because this is definitely greater than 0, because that's positive, and that's positive. So this is greater than 0. So greater than 0, therefore, I'll just be super clear, guys. As d2s dx squared is greater than 0, this x gives a minimum. Okay, that's part B done. Then part C, 1 mark only, says find to 3 significant figures the minimum value of s. Okay, so now I just have to sub in this x into this s. Now this is where I will choose the less rounded version. So s is equal to 6 times x squared, so that's 4.9324 squared, plus 1440 over 4.9324. And this is equal to, well, I'll just do this on the calculator. It's 6 times 4.9324 squared plus 1440 over 4.9324 gives us 437.9. 437.9 to 3 significant figures, 438. And I guess we're talking about, well, it's centimeters squared, but the value of s is 438. Okay, that, guys, is question 9. Question 10, given that, f of x is this, given that f of x can be written in this form, find the value of d, e, and f. Okay, so this is basically, guys, completing the square. Now, you can do this bit on the calculator, guys. In fact, a and b can both be done on the calculator. Let's do it, though, without the calculator first. So, f of x equals, I'm going to take out the minus, and I'm going to have, I'm going to take out the minus, and then I'm going to have x squared, and then I'm going to do minus 6x. Okay, and then leave that minus out there, square brackets, I half the 6, x minus 3 squared. I then have to subtract 9. I won't go into why right now in detail, but this is how you complete the square. And, well, that's it. There's no number here. So then this equals minus x minus 3 squared, and then minus is plus, so it's plus 9. So that means d, e, and f. So d equals -1, e equals -3, and f equals 9. Okay. Then he says find the maximum value of f of x. Well, guys, if you know how this all works, the maximum value is 9. It is the y, it is the k, it is the y value when x is 3, so it's 9. And then the value of x where this occurs is the 3. So it's the value of x that makes this 0. So 3 minus 3 is 0, so x is equal to 3. Now, guys, you can put that into your calculator, and it gives you the minimum. So it gives you the coordinate. It'll give you the coordinate 3, 9, and then you have to just put it into this form. Anyway, that's how you do it without the calculator. That's part, well, that's A and B, guys. I think that's pretty nice for question 10. Okay, let's go to part C. Curve C has equation of y equals f of x. S is this equation. They intersect at 2 points. Find the coordinates of each of these 2 points. Okay, also not a bad question, guys. I can just equate them. So to find where they meet, we equate them. 6x minus x squared equals x squared minus 4x plus 8. Let's make this a quadratic. 2x squared. Subtract the 6, so this is going to be minus 10x plus 8 equals 0. Divide by 2. X squared minus 5x plus 4 equals 0. This one's an easy one to factorize, guys. It's just x minus 4 times x minus 1. Make sure you know how to do that, which gives us x equals 1. So this equals 0 or this equals 0. X equals 1 or x equals 1 or x equals 4. Now we need to get the y because well, he wants the coordinates. So how do I get the y? Well, I sub into this. So I can sub into either this or this, guys. So let's just do the first one. F of 1 is equal to 6 minus 1, which is 5. And then f of 4 is just going to be 24 minus 16. Let's write that. 24 minus 16, which is equal to 8. So therefore, the coordinates are the coordinates of each of the points are 1, 5, and 4, 8. Okay, that's part C. Part D. The finite region R is bounded by the curve C and the curve S. Use algebraic integration to find the area of R. Okay, so what we have, guys, is one of these is a happy face quadratic. It's this guy, and one of them is the sad face. So we want this. We want this area. Now the way we get it is we integrate. So this area is equal to the integral between the two curves. Now, to find the area between the two curves, guys, we do one minus the other. Now we want the one above minus this. So we want the negative quadratic minus the positive quadratic, because that will give us this area here. So we'll do this 6x minus x squared minus this one, x squared minus 4x plus 8 dx at the end, big bracket, I guess. And then the limits are actually the x coordinates of the intersecting points. So intersection points. So it's 1 and 4. So that's the integral that we're going to do. Okay, let's expand before we integrate. This is going to be, well, let's see if we can do this in one go. Minus x squared is minus 2x squared. 6x plus 4x is plus 10x, and then just minus 8. So all of this dx. And now we're going to integrate it and hopefully get the answer. Let's do this here. Okay, so this equals the integral. So I'm going to put a square bracket. This is minus 2x cubed over 3 plus 10x squared over 2 minus 8x from 4 to 1. And now we're going to sub in our 4 and we're going to sub in our 1. So this equals, subbing in our 4, this is negative 2 times 4 cubed over 3 plus 10 times 4 squared over 2 minus 8 times 4, and then subtract, sub in 1. Let's see if we can do all this in one go here, guys. Sub in 1. I'm actually going to get rid of this and do this. Okay, sub in 1, so it's negative 2 over 3 plus, this is just a 5 actually, guys, so plus 5 times 1, which is 5, and then minus 8. And then you can do all this in the calculator, guys. I'm going to do it. I think I can nearly do it more quickly without the calculator. This is 64 times 2, 128, so it's minus 128 over 3. This is plus 4 squared is 16 times 10, 160 divided by 2 is 80. 80 minus 32, and then subtract, this is minus 2/3 minus 3, so it's minus 3 minus 9 over 3 minus 2 over 3, which is minus 11 over 3. That's going to be plus 11 over 3, so it's minus 128 over 3 plus 11 over 3, and then plus 48. Okay, and this, guys, okay, fine, I am going to cheat here. Well, not cheat, but I'm going to use my calculator. Okay, negative 128 over 3 plus 11 over 3 plus 48 gives us exactly 9, which is the right answer. 9, and is it in centimeters or anything? No, it is not. So that is the answer. Okay, done, guys. That is question 10. Question 11. The points A and B have coordinates this and this. Find an equation for the line AB. Okay, guys, that should not be difficult. Well, at least it should be very familiar to you. First, we get the gradient, m. It's y2 minus y1, which is 6 minus 3, over x2 minus x1, which is 5 minus 1, which is 5 plus 1, 3 over 6, which equals 1/2. And then the equation of the line, guys, my preferred formula is y minus y1 equals m into x minus x1 for the equation of a line. So I get y minus, I can choose any point here. I think I'll choose 6, guys. Y minus 6 equals m, which is 1/2, into x minus 5. So that's using, this is my x1 and this is my y1. And that's why I prefer that equation, guys, because I'm done, because he didn't say to put it in any particular form. So we're good. That is A done. Part B. The point P divides AB in the ratio 2:1. Show that the coordinates of P are this. Okay, so guys, if the coordinates of P are 3 to 5, that means we need to go from minus 1, 3. Let's just draw it here like this. Minus 1, 3 to, I don't know, let's say 5, 6. Okay, so the point P, because it's in the ratio 2:1, the point P is going to be somewhere like here, where this is 2 of these is 1 of these. Okay, so what we do is we say minus 1 to 5 is 6. So that distance, let me just show you, this is not drawn out, guys, so you can see it. This distance is 6, and this distance is 3. Now, guys, if it's in the ratio 2:1, so you can actually see it, and a diagram here would actually work, but I'll show you the more technical way to do it. So this is from here to here and here to here. So I divide the 6 in the ratio 2:1, and I divide the 3 in the ratio 2:1. So that would mean this is 4 to 2, and then this would be 2 to 1, like that. So the ratio then would be, or sorry, the point would be minus 1 plus 4, which gives me the 3, and then the 3 plus 2, which gives me the 5. So that's how we get it. That is our 3, 5. However, let me just show you how to write it kind of algebraically. So I'm going to do minus 1. So if it's in the ratio 2:1, it's like 2/3 to 1/3. 2/3 to 1/3. So I'm going to do, let's do x coordinate. The x coordinate is minus 1 plus 2/3 of the distance from minus 1 to 5, which is 6. So 2/3 of 6, which is minus 1 plus 4, which is equal to 3. And then the y coordinate, let's do it over here, the y coordinate. In a show that question, guys, it's always good to be like crystal clear what you're doing. And then 3, so this one plus 2/3 of this distance, which is 3. So 3 plus 2/3 of 3, which is 3 plus 2, which is 5. Therefore, P 3, 5. Okay, part C. Over here. Given that the radius of the circle which passes through A, so guys, this is a, okay, well, sorry, I haven't read this, but the point C with coordinates MN is such that CP is perpendicular to the line AB. Okay, so now, guys, I'm going to actually draw this again. So I've got AB like this, and I have a radius of I have a point C such that CP, let's get our P here again, guys. So this is our P, this is our A, and this is our B. So CP is perpendicular to the line AB. Okay, so CP is somewhere down here. Okay, so this is C, somewhere perpendicular. Okay, given that the radius of the circle which passes through A, P, and C is 5, find the value of M and N. Okay, so, right, let me just show you what's happening, guys. Again, it's always worth drawing something here. So if we go through this, there's a circle that's going to go through this point, and this point. Now, let me see if I can draw that, because this is going to obviously be kind of tricky. Okay, terrible drawing. Let me just, let me get a circle. First of all, hang on, guys. I need a correct circle. Okay, fine. Now I'm going to put this. Fun fact, guys, if you have 3 points, you'll always be able to get a circle that goes through them perfectly. Okay, there we go. So there's a circle. The radius of the circle which passes through APC is 5. Okay, so that means there's a radius somewhere here that goes through A and C, which is 5. So this center is 5. Okay, so this distance here has to be 5, and this distance here has to be 5, and this distance here is equal to 5. Okay, this is 5 here. Okay, now I just realized, guys, how we're going to do this question. This is, because I was just thinking, how am I going to do this? This is quite a tricky question. This is also 5 here. Now, I was thinking, because this does look a bit like a diameter, but there's no way, we cannot say that AC is the diameter, but because of this perpendicular thing here, he says, and this is how my drawing has actually helped me figure this out, because I was actually thinking, how on earth am I going to do this? Because I've drawn this, because this is a right angle here, because he said perpendicular, and that's obviously, I had that in the back of my mind, that's key to the question. Because this is perpendicular and it's on a circle, we know that this has to be the angle in the semicircle. So what happens is, because A and C are on the circle and P is on the circle, and this is a right angle, this actually does have to be the radius. So this actually is a straight line. So I know that, okay, C is MN, P is 3,5, and A is -1, 3. Okay, now because I have 2 letters, 2 unknowns, I need 2 equations. So what I'm going to do is, well, I'll get 2 equations. One of them I can get from the gradient. So I know, let's call this equation 1, that n minus 5 gradient y2 minus y1 over x2 minus x1, this minus this, equals the negative reciprocal of 1 over 2, which is negative 2. So this becomes n minus 5 equals negative 2 into m minus 3. Okay, equation 2, I will get, because I now know, guys, that this is the diameter. So just to be clear, this is a diameter because of what we said about this being a right angle. Circle theorem. But so the distance is just double the radius. The distance from the two points. If the 2 points join to make a diameter, obviously the distance is just the radius plus the radius. So this distance formula, this is our x1 minus x2. So let's say this is m. This is m plus 1 squared, m plus 1 squared, plus n minus 3 squared. So this minus this squared and this minus this squared equals the distance, which is equal to 10. Square both sides, I get m plus 1 squared plus n minus 3 squared equals 100. Okay, now to solve this, guys, I think I will just, I don't know, this is like an IGCSE simultaneous equation where one of them is non-linear. So I can I think let's just get n here. So n minus 5 is equal to negative 2m plus 6, which means n is negative 2m 6 plus 5, which is plus 11. Then I'll sub that into here. That's right, it's I'll say sub 1 into 2. This gives me m plus 1 squared plus, now instead of n, I'm going to write minus 2m plus 11, but there's plus 11 minus 3, which is plus 8 squared equals 100. Now I have a quadratic. Expand all this out because I'm going to do this quickly. M squared plus 2m plus 1, don't mess that up, plus this squared is 4m squared minus 32m, I'm doing that quickly, guys, plus 64 equals 100. Make sure you know how to do that. Then I have 5m squared minus 32 plus 2 is minus 30m, 64 plus 1 is 65, minus 100 is minus 35 equals 0. Divide by 5, m squared minus 6m minus 7 equals 0. Factorize this, guys. Again, I'm going to do it quite quickly. M minus 7 times m plus 1 equals 0. M equals 7, or m equals negative 1. Now he does say, guys, here, I believe, m is greater than 0. So always when you get an answer, go back to this. Go back to the question. I read that and I remembered it, but always go back and go, well, that means m has to be 7. So I'm going to just move up to here and say, okay, m is greater than 0, therefore m equals 7. If m is 7, n equals minus 2 times 7 plus 11, which is negative 14 plus 11, negative 3. Okay, so the value of m and n we have m equals 7, m equals 7, n equals negative 3. Okay, part D. Well, the point D with coordinates PQ is such that AD is perpendicular to the line AB. AB is perpendicular to the line AB, and the line DC is parallel to AB. Okay, so guys, just so we're clear on what's happening here. Okay, this is perpendicular to here, and okay, hang on. The point D is such that the line AD is perpendicular to the line AB. Okay, so that's perpendicular and parallel to the line AB. So like this. Okay, so okay, fine. Sorry, the reason I was confused is because I saw trapezium, but that's the next question. Because this is clearly a rectangle, because this has to be a right angle, and this has to be a right angle. Okay, so find this point here, guys. This is D with point PQ. Okay, 3 marks. Number of different ways to do it. I think I am going to, again, guys, I have 2 letters, so I think I'm just going to do, I'll do the 2, just to avoid quadratics, I'll do the 2 gradients. So I can say the gradient of DC is 2, and the gradient of AD is, sorry, the gradient of DC is a half, and the gradient of AD is negative a half. Sorry, that's a half, that's negative 2. Okay, so let's go down here. I'm going to say gradient, I'm running out of colors, gradient of DC. Gradient of DC has to equal a half. Okay, so it's n minus q, or q minus n, but I know n is negative 3, so it's q plus 3 over over p minus m, so p minus 7, and this must equal 1/2. Rearrange or cross multiply, I'll get 2q plus 6 equals p minus 7. There's equation 1. Now I want gradient AD. Gradient AD. This is y2 minus y1, so it's q minus 3. Q minus 3 over p minus minus 1, which is p plus 1. This equals negative 2. Cross multiply, q minus 3 equals negative 2p. Negative 2p minus 2. Okay, now I have simultaneous equations. Let's just solve these however we want, guys. I am going to do it, well, let's just tidy this up a bit. This is 2q minus p equals minus 13, and this is q plus 2p equals q plus 2p equals 1. Let's make the p's the same. So this would become 4q minus 2p equals negative 26. Multiply everything by 2. Then I can just add that to this. So 4q minus 2p equals negative 26. And then q plus 2p equals 1. And then I just add these two. Add them. This plus this is 5q. This plus this is 0. This plus this is not negative 25, which means q is equal to negative 5. If q is equal to negative 5, then, well, I can just sub in here. Negative 5 is equal to 2p. Sorry, negative 5 plus 2p equals 1. 2p equals 6. Add the 5 over here, which means p equals 3. So over here I'm going to write, guys, p equals 3 and q equals negative 5. Okay, that is part D. D, guys, I should have written it here somewhere. Okay, finally, find the area of the trapezium ABCD. Okay, trapezium, guys, believe it or not, I actually don't mind this question because I think I know all the lengths. So let me just first, I'm going to copy this, copy, and I'm going to bring it over here so we have some space. Okay, so here's our copied diagram. So firstly, guys, what I'm going to do is I'm going to change this mn. So we know we found m and n, guys. M was 7 and n was -3. And also we found our d, we found our p and q. This is our d, p and q to be 3, -5. 3, -5. Okay, now he wants the area of the trapezium A, B, C, D. Okay, so this is going to be A, B, C, D. Okay, why is he deleted a lot of my lines? Whatever. So it's this green trapezium, guys, that he's after. These two lines are parallel, this one and this one. So this is in our formula. I'll write it here, guys. Our formula is A plus B over 2 times H. That's the formula for the trapezium, where the A is one of the parallel lines, the B is the other parallel line, and the H is the perpendicular, which is going to be this line here, or you could actually use this one here, it doesn't matter. So let's just show you what I mean here. Our A is AB, our B is DC, and our H is, let's go with less minuses, PC. Our H is PC. Okay, so all I have to do is get the area, get the lengths. So let's do them separately. So AB is the square root of, now actually guys, I need B, which they gave us at the start, which I've forgotten. B was 5, 6. Okay, so I have B, it's 5, 6. So the length formula, guys, hopefully you know this is x1 minus x2 squared plus y1 minus y2 squared. So it's 5 plus 1 squared, 5 plus 1 squared, plus 6 minus 3 squared, 6 minus 3 squared, which equals the square root of 36 plus 9, which is root 45. Okay, DC, the length DC, is the square root of 7 minus 3 squared, plus -3 plus 5 squared, which is going to be the square root of that, guys, is 16 plus 4, which is 20. So DC is root 20, and then let's get PC. The length PC is 7 minus 3 squared plus -3 minus 5 squared. This is equal to 4 squared, which is 16, plus 8 squared, 64. That is equal to the square root of 80. Okay, so now I have my lengths. Let's just sub these into the formula. So the area equals A plus B. So that's going to be this plus this. So it's root 45 plus root 20 over 2 times root 80. You could do that on the calculator, guys. I'm just going to do it here. This is actually, this is 3 root 5 because it's root 9 times root 5. This is 2 root 5 because it's root 4 times root 5, all over 2 times, this is root 16 root 5, which is 4 root 5. All of this is multiplied. This goes once, this goes twice. Multiply out, I get 3 times 2, which is 6. Root 5 times root 5 is 5. That's 30. And then 2 times 2 is 4. 4 times 5 is 20. 30 plus 20 equals 50, whatever, centimeters squared, whatever it is. Okay, so there you go, guys. Obviously, difficult question. I think that's the last question of the paper, so that's what to expect. Okay, I'll see you for paper 2.